Okay, assalamu alaikum jami'an. So today we're going to continue on the lab of the creating DHCP server or configuring DHCP server in the network, in the LAN network, and how to enable the DHCP server services to be to be implemented on the end devices and on the end devices. I don't want to go again into the theory part, because we have been discussing the main rule and the mechanism on how DHCP server is working. So what I'm going to do in this lab is that I'll immediately go to the practical scenarios. Roughly, we have two scenarios. We have the first scenario, which the scenario it shows or demonstrates the basic DHCP server scenario, where the server itself, it exists in the same network as the other hosts who are seeking to get an IP addresses automatically from the server. Okay, and then the second scenario, which it is actually a little bit more complicated or extended scenario, and actually this is the most realistic scenario to say. In the real implementation, most of the scenarios are existed in this layout, where the users who are about to be assigned with the IP addresses automatically are usually existed in different networks, but however connected to the same router. Okay, so the DHCP server here is connected to another network than the previous than the rest of the hosts. We're going to we will be learning how is it going to how is it going to happen here that the IP addresses could be assigned dynamically. Okay, so let's just go back and work with the first scenario. In this scenario, I do not want to re-explain this to you again, because if you can refer to the previous recording or the latest recording, you will find all of these details, right? So I'm going to start immediately with the first practical scenario. So the scenario states that the above topology, it depicts a network. It depicts a scenario with whereby the network address is being given here to perform the following task. You have been given this network address or this kind of address space, and you are going to perform this scenario. So task A, you are requested to design the topology in a packet tracer, and then you are going to use the address space to design an IP address based on the following scheme. Of course, here the PCs 1, 2, 3, which are the end devices, are not going to be assigned with a manual IP address or static IP address, meaning that we're not going to manually assign the IP addresses. Rather, we will be only assigning the IP address for the DHCP server, and also configure what we call the DHCP pool over the over the DHCP server. As all of you knows that as all of you know that how DHCP is working, it works by usually creating or by what we call as IP addressing pool, whereby the IP addresses are actually being defined here. The range of IP addresses, specific IP addresses, is defined in the server, and under the DHCP service, and then these IP addresses are later going to be used in order to perform what we call automatic IP address assignment. I'm just referring to the same file that we were working with in the previous lab. You can see here, so I have highlighted this. So 195.120.3 okay, .0. Okay, so that's /25. So /25, this means that I think now you should be able to remember, and you should be able to be familiar with with these kind of indications or notations. So /25 25 indicates that we have a class, a network address which has a specific size. The size of the address is from 195.120.3.0 until 127. How did we get that? It is by calculating the the number of host bits. Okay, so /25, if you remember, this this value here, it identifies or indicates the number of network bits So if you refer back to the subnetting, skills, you will find that the 25 bits here are arranged or are distributed over, one octet, another octet, and third octet, and then the first bit from the fourth octet. So 8 plus 8 plus 8 plus 1 octet from here. So that will give us the /25. So the first octet, the value of the first octet, if you remember, we have 8 bits, right? So starting from the leftmost side, so the value of the first bit from the leftmost side is 128. Okay, so borrowing 1 bit from that octet, so we will be remaining with another 7 bits. So the 7 bits here will be used for the rest of the bits. Let me just highlight them in blue. So the rest of the bits beside the like the 8th bit here, which has been borrowed, because we have /25 here, so we have 7 bits, so that will be 2 to the power of 7, and let me just write it down here. So that will be 2 to the power of 7, all between two brackets, minus 2, which will be the network address. Anyway, it doesn't matter whether minus 2 or not, but actually this is the equation. The equation without, including to determine the number of addresses, to determine the range of addresses within the subnet, including the network address and the subnet mask, or the network address, and the broadcast address. That will be n. That will be 2 to the power of n, where n is equal to the number of host bits. And we have got this from from this information here, knowing that the maximum number of bits, or the total number of bits in the IP address, is 32. So 25 represents the number of network bits. So if we minus 32 from 25, for 25 from 32, that will be 7 will be remaining as a result. So that will be 2 to the power of 7 will equal to 128. Okay, so because we are starting from 0, okay, so this is a number, but because we are starting from 0, so then we will be the range of addresses will be from 0 to 127. So in other words, so the IP address range starts from 195.120.3.0 and then .1, .2, .3, .4 until all the way until 127, which is the last IP address in the range. Clear? So this is how we obtain this information. It's very important, and that's basically the first. This is the first procedure you need to think of whenever you've been given an IP address with a prefix like that. A prefix which is none of the none among the well-known prefixes. I'm talking about the well-known prefixes such as the /24, /16, or /8. In other ways, those prefix values which describes the classful addresses. But since we are no longer working with the classful addresses now, /25, 26, 27, and any other prefix other than /24 or /16 or /8, any other prefix, this indicates that that particular address space belongs to the classless address, okay, such as that one here. Anyway, so you need to get yourself familiarized with this. You need to get yourself familiarized with how to work with the those kind of information here. So from that, we were able to determine the range of IP addresses, and number 2, here we are able also to determine the subnet mask address, because we are really in need of that, of this information. So the subnet mask here, we are going to count for all of the network bits. So the network bits here is /25, so that will be 11111 in the first octet. Second octet, that will be another in second octet also the same. We'll have all ones, and also the third octet will be the same, all ones. So that will be, and in the last in the last octet we have only 1 bit borrowed, because in order to to accumulate 25. So that will be 8 plus 1, so that will give us 25. Anyway, so if you calculated all the ones here, all the ones under each octet, you will get 255. In another word, the IP address I mean, like the subnet mask of the, I mean, like of that kind of IP address is to convert all the values of ones into all the, I mean, like all the values that has ones into 255. Okay, because in another word, if you remember, as I told you before, so that was supposed to be something like that. So, and then we have another 8811, and then that will be, I mean, like the second, you know, set here will belong to the second one here, and the first one here will belong to that one, so that if you add them up, and the third one, let me just put it down, will belong to that one here. So the third one here belongs to that one here, because so that, I mean, like, and the fourth one, of course, I mean, like the fourth octet, which is this one, the last octet here, will have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this means that the first octet, I mean, like the first binary will be turned into 1, and then the rest will be 0. Type. Now, if you convert these into a decimal, so of course you will get this value here. This is why here we have 255, 255, 255, because all of the sets here are actually being represented in ones, not in zeros, except for the last octet here, where we have only the first, I mean, like the leftmost side octet is only 1, the leftmost side bit is only 1, and the rest is zeros, because those are the you know, the binary, I mean, like the bits that belongs to the host, excluding the first one in here. Okay, so this is why here we will able to get 255.255.128, which is the value of the first octet here. Don't forget actually that kind of arrangement: 1 to 8, 64, you know, 32, 16, 8, and 4, 2, and 1. So you need to actually, you know, get yourself familiarized with that by memorizing them, by, you know, following the, you know, the skills that I have been, you know, teaching you before, how to, you know, identify the value of this. Okay, type. So that we have, I mean, like, since we have these information, we can just now go ahead and assign the IP address. So let's just go into the packet tracer. So I'm going to open the packet tracer now tool and work with it to create the network. So I'm just going to briefly create that network. So let me see, I have, you know, PCs 1, 2, 3, and then I have one server. In the middle, I have one switch PT, and so that's it. So the networking will be all, I mean, like the cabling will be all crossover. Oh, sorry, straight through. So all to the fast Ethernet. Okay, so and that will be for the second one and the third one. So this is it. Okay, so let me just put this all together beside each other, and all right, so that's it. So now we are going to go for the static IP addressing. So static IP addressing should be assigned to the server, as you know, according to the information in here. But the dynamic IP addresses, of course, that's not going to be our own side. It is that we will only be configuring the DHCP server statically and enable the, you know, the DHCP service, and then by that we should be able to have the dynamic IP address assignment automatically being inherited to the PCs. Okay, so let's just go to the, first of all, let's just go to the desktop from here. And so with that, I'm going to use the following the information in here, the instructions. So the DHCP server will take the last host IP address in the network range. So what is the first host and the last host? We have been defining them in here. So knowing that that will be actually the last address in the range, it's not the last host طبعا زي ما احنا عارفين. So starting from 0, so that 0 will be the network address, and that one will be the broadcast address. So between them, there will be the last host. So 1 host like one value minus this value will give us the last host IP address. So in another words, the host IP address will be 195.120.3.126. Okay, so I'm able to get the last host IP address because this one 195.120.3.127 is the last IP address in the range. And as you know, if you remember in the last class of the subnetting, we know that the last IP address in the range, it is used to be defined for the IP for the broadcast address. So here we are not talking about the last IP address in the range, we are talking about the last host IP address. And I told you need to focus between, you need to differentiate between when you've been asked to refer to the last host IP address or to refer to the last IP address in general. Okay, there is a difference here. The difference is just only, one order of the address, Instead of referring to the last, to the last IP address in the range, when we refer to the host here, it is about to refer to the host IP address. Okay, so you can just get yourself trained about that by referring to the subnetting class, where we identify and explain those terms. Okay, because now the host after this, like the IP address after that, the IP address that follows this IP address, that should be for the for the broadcast address, which is 195.120.3.127. Okay, so .126, that's the last host IP address. Then what is the first host IP address? Then the first host IP address will be following the network address, because of course the first IP address in the range of in the range of the subnet addresses, that will be 195.120.3.0. that's the network address, and then 195.120.3.1, that will be the first host address. In another word, the host IP addresses can be assigned starting from 1 all the way until 126. Okay, so let me just use the 195.120.3. the last host IP address 126, and here my IP address, my subnet mask, of course, it is going to be 128.255.255.255.128, and a default gateway, we do not have a default gateway, so you can just simply leave this blank, both fields here, because we're still just working in the same network. Okay, so we'll close that, and now close this again. So here we have been configuring B. Okay, so based on the following, as I told you, you don't need to bother yourself about PCs 1, 2, 3, because here, since they have been identified or highlighted with the dynamic IP addressing, so this means that we need to configure the DHCP server first in order to activate the dynamic IP addressing first. So I'm going to postpone this step here until we go for the step C, which is the configuration of the DHCP pool or the DHCP service in the server. Okay, so now we need to create a pool. Okay, where we create the pool here, it is to be created in the DHCP server under services. We go to DHCP in order to identify now, or in order to let these PCs get a source of addresses, because they need to know from where they should get the addresses. There should be actually here a configuration setting, a specific configuration that highlights a specific range or pool. We call it a pool of addresses, where it is defined as a range of addresses where these PCs are going to be automatically assigned with. Okay, so who's the one who's going to assign? That will be the DHCP server. It is not the PC who is the one who will select, I'm going to select that IP address or that IP address. It is the DHCP service here is the entity, or it's the the main responsible for assigning the DHCP for assigning the IP addresses. So I'm going to leave the pool name as it is. So first of all, let me just turn the service on. That's the first thing you're going to do here. And then the second thing here, since we are working in the same LAN, we do not need to change anything in here. So we're going to use the default gateway and the DNS server. So that's the default IP address, all zeros. So that's the IP address that identifies or indicates the default IP address. Okay, type. What's the information that we need to consider then? As you have been told here, the default gateway, you should leave it as it is, as well as the DNS address should be left as it is. So starting the starting IP address. So from which range should we start? So you have been asked in this scenario to use, to have the assigned IP address starting from 60. This means that, the first IP address that is going to be assigned by the DHCP, it's not going to start from 1. It's not going to be like 195. It's not going to be 195.120.3.1 or .2 or .3. Although we have all this ranges, belongs to the host IP address. Okay, but since here we have the configuration to start from 60, then the first IP address is going to be start for the, is going to be assigned for the host. It will be 195.120.3.0.3.60, sorry, and then starting from 60, 61, 62, all the way until the specific number of addresses that is going to be assigned here. Okay, so this is the purpose of this. So this will be the starting IP address for the first host. Okay, the subnet mask should be determined based on the prefix 25. We all know that the prefix 25 should be 255.255.255.128, as you can see here. So we don't need to change anything. Now the maximum number of users or hosts. So how many addresses do you want to enable this pool to feed? This pool should be responsible for assigning a maximum number of addresses up to how much, and that will be the value here. Okay, so we can change it according to the scenario, according to whatever value you've been given here. So that will be 40, for example, and it might be different, by the way. All these values can be different according to the scenario. It could be now it is 40. It could be in another scenario it could be given like 50 or 60, or maybe in your exam, if there is a question from this type which happened to be in the exam, so it might be assigned to another value. So you need to stick you need to stick with the whatever information is being presented in the scenario so that you can use them. Okay, so in this case, let me just put 40. So this indicates that starting from 60, this address pool is able to should be responsible for assigning a maximum number of 40 IP addressing starting from 195.120.3.60, starting all the way with 40 IP addresses. So that will provide until we are expecting that the last IP address here within this pool will be 195.120.3.100, or like 199, sorry, not 100. Okay, because we are starting from 60. Clear? So that's the idea there. So we are done here. So once you have been configuring these two things, so I think in this scenario those are the two most important things, because otherwise you didn't do anything else. Even with that one, if you have determined the IP address correctly, if you have determined the static IP addressing of the server correctly, stating that the subnet mask is that one here, 255.255.255.128, then you should have no problem. You will be automatically finding this, as you can see here. Okay, but let me tell you that you will need things has been changed a little bit. This is because we do not save. We have to save actually before you even move to any tab, anyone here. Before you click to anyone here, you need to click save, so that you have the so that you have that the changes have been applied and recorded. Not add will add a new record. We're not going to use that now. Okay, so click save to save the settings, and then that's it. So let's just test our scenario. From here you can see that the DHCP now the DHCP is being deactivated. So now let's just activate the DHCP to see that. You can see that starting from 195.123.60. So here we have been successfully enabling DHCP in this PC, and also in this PC, if you click DHCP here, of course, starting continuing after 60, that will be 61, and then until until a total number of 40 IP addresses, there should be no problem in assigning different IP addresses. And you can see here that all the information are being fitted accordingly. So 195.120.3.62. So now you should have no problem in providing the connectivity or testing the connectivity. So let me just assign, or like let me just ping the first. I mean, like I'm now in PC2, I'm going to ping PC0, which is the first PC. So ping 195.120.3.60. Of course, I should have no problem. I even can ping the server itself. So if I want to ping the server, that will be 126, and I also should have no problem. So now I'm sure now that all the PCs are able to ping each other, and even all the PCs are able even to ping the server itself. Okay, so this is all from the first scenario. So let's just move to the second scenario there. So what is the IP addresses? What are the IP addresses that we have been assigning? I think I'm going to leave this for you to to fill it out, because just now we have been getting these IP addresses from the DHCP if you were just observing. Okay, and then steps E and F, so those are related to the testing and the verification of the connectivity. So for example, ping PC1 from PC3 and PC2, meaning that you will need to go to PC3 and PC2 and ping PC1. I'm sorry, you need to go to PC3 and ping PC1 from PC3. It means that you will need to open the terminal from PC3 trying to reach PC1. Same goes for here. Open the terminal from PC1 and try to reach PC3, and then you'll be able also to ping the server as we have been displaying just now. All right, so let's just open up the the topology a little bit more and consider like much more configuration in there, assuming that there will be assuming that the server might be existed in a different network, and it's actually the most, as I told you, that's the most practical scenario. In most of the scenarios, you're not going to find it, you're not going to find this case as the the major case or the most realistic case. Most of the real implementations consider that that scenario here, where the the servers, or the server pool we call it, or the server's farm, whether being like a DHCP, DNS server, HTTP server, they're usually existed in a separate network from the end users in any company. And these servers should have to be configured accordingly, so that they provide a service even over the different networks. So this means that we should provide like inter-networking or like inter-LAN DHCP services. Okay, let's just go through the details so that you can easily understand that. So okay, so the scenario starts by redesigning the above topology. So of course here, what you have been noticing here is that by only adding one router, but of course adding the router here have splitted the network domain into two domains. We have like one domain here and then another domain. This is why here we're going to work with two LANs, or like two LAN IP addresses. Okay, so you've been given these two subnets. So 192.168.10/25, that will be to describe the network between the router and the server here, and the second network should be it should be used to describe the switch LAN network, which is those like this part in here. Okay, so how many DHCP addresses, how many DHCP address pools do we need here? Since we have like how many networks, you will need to define how many networks. Then how many DHCP pools should we be able, should be defining here? Should we define in this scenario? Meaning that in the DHCP server, how many address pool we should, we should define. In the previous scenario, if you remember, we were only defining one DHCP pool, right? Because we have only one LAN. But here, since we have two LANs, then this means that you will need to work with two DHCP pool. Although, yes, we assume that there are no, now in this, as you can see in this topology, there are no end devices, but only the DHCP server in this LAN. But let's just assume that there might be another devices who might be later on connected to that network, the network from the router to the server. Okay, so this is why here we will be having one DHCP pool here that describes this network, or that enable the server to assign IP addresses for whoever, for whatever end device which might be connected to this network, and of course, another DHCP pool to describe or like to enable the connectivity, the DHCP connectivity, IP addressing connectivity for the different PCs here, or the different end users. So those will be two pools. So create a static scheme for the DHCP server. We need to create a static scheme as what we have been doing in the previous one. So the IP address of the server, of the DHCP server, that should be the last host IP address in the subnet, this one. If you remember, I mean, like if you notice here, I have brought you another IP address because I would like you actually to practice more. I do not want to keep just using the same IP address, because that will be a good opportunity for you to to rethink again, trying to work with different addresses on how to extract the first host IP address, the last host IP address, how to extract the network or the subnet address, the broadcast address, and also the subnet mask. Okay, so since we have the same prefix, then the subnet mask should be the same. Should be the same, of course, as the first scenario here. You can just easily or like blindly now be able to determine this. /25, this means that we have 25 bits. If you if you divide them over 4, assuming that 4 is the 4 octets over of the IP address, so that will give us 3 point, right? So this will be now 255. So this means that the subnet mask will be same as the first one here. So that will be 2, or like subnet mask SN mask will be 255, 255, 255, 128. And you know already what is 128 and what is 255, right? Of course, same is going to be for the, for both networks, by the way, because both of them are /25, or they are using the same prefix. So the subnet mask will be the same for both. Okay. So now, in the first network here, so that's the subnet mask for both. Let me just take this subnet mask for both LANs. Let me just put it down to be clear, and I'm going to use this here again. So now, what is the first IP address in this topology? What in this subnet address? What is the first IP? What is the first host IP address? I'm not talking about the first IP address. Of course, the first IP address should be 192.168.3.0. Sorry, .1.0. That will be the subnet address. Okay, that should be the subnet IP address. And now, what is the first host address? The first host address, that's the following address after, the subsequent address right after the subnet address. This is going to be the first host address in the subnet. So what is the range of the IP addresses in this network? The range of IP addresses in this network is the same as the range of IP addresses in the previous network, because here, as I told you, we're still using the same prefix. It is the prefix that decides what is the size of the IP address, and the information that we use in order to know what is the size of the subnet of a specific subnet. How many addresses are there in that subnet? It is the prefix that could be used in order to determine this, as I told you. So the prefix here represents the number of network bits. So /25, this means that 25 network bits are being used. Remaining, if we minus them from 32, so then we will be remaining with 7 bits. Those will be for the host IP addresses. So this means that the number of addresses from the host bits are 2 to the power of 7. That will give us 128 IP addresses. Since we are starting from 0, then there will be from 0 to 127, sorry. That will be 0 to 127, okay, IP addresses. These are the IP addresses, the range, starting from 192.168.1.2.0 all the way until 127. Okay. Now the subnet address will be assigned to the first address in the subnet, which is 0. Now we are starting with the first host will be 192 168.1.1. Okay, so that's the first host address, and then last host address all the way until 192.168.1.1.126, right? And then the subnet, the broadcast address will be 192.168.1.127, right? Because 127 is the last host, is the last IP address in the network. طبعا this is the broadcast address. Clear? So here we are able to get all of these information from this. You can see that only from this details here, only from the details we are given here. Okay, so let me just cut that. Okay, so I will be just putting it like this so that it can be clear for you. All right, so this is it. So now you can do the same thing, by the way, for the second one. Okay, for the second subnet, the subnet that describes the router to the switch LAN, starting from, of course, so the first IP address will be, now let me just put this also for you, so that, because I think we're going to use it even now. So do we have enough place here? We can copy paste this. Yeah. So 192.168. Let me just go. Let me modify, because now I'm working with this. I'm going to identify the information for that network. So the subnet address will be 128. That's the first IP address in the subnet. Okay, and the first host address will be 129, and the last host address will be 253. Okay, isn't it? So the first one, yeah, and that will be 128 plus 128, 254. Okay, so 253, it's the last host IP address, and that's 254. This is the broadcast address. واضح? So that's it. So let's just now go with the with the settings. So how many DHCP address pools are needed? I think now you already know how many address pools do we need here, since we have two networks. So going to task C, so create a static IP addressing for the DHCP server. So now the DHCP server will have the last IP address in the range. So that's this is the network that describes the DHCP server here, the first one. So what is the last IP address in this range? This will be the last host IP address. I'm not talking about the last IP address itself, because if it is the last IP address, that will be the broadcast address. But we are talking about the last host IP address. So here we are talking about this range. What is the last IP address in this range? بمعنى آخر. So this will be, of course, 192.168.1.126. So 192. Let me just open Packet Tracer again and try to redesign the network. So 192. Router PT, so that's the router here, and that's a switch also here, and there should be PCs 1, 2, 2, 3, and then we have one server over here. Okay, connectivity will be crossover from the router to the server, fast Ethernet to that one here, and then so that will be fast Ethernet 1/0, first fast Ethernet, and then we assign the rest of the Internet interfaces to the rest of the PCs. All right, so that's it. Okay. What's the problem with that? Okay. All right, so let me just now. So we have designed the. So now I'm going to follow the same instructions in here. So I'm going now to create a static IP addressing for the DHCP server. So the first thing you need to go here is to go to the server control panel, go to desktop, to the desktop tab, and click on the IP address configuration. That should be static, of course, because as I told you, we are working with the DHCP server, and the DHCP server should be given a static IP addressing. Okay, only the only the end devices, only the PCs or like the end hosts, such as the PCs, the laptops, those are the the devices that to be assigned with the with the dynamic IP addresses. Even though even about the now later on we're going to see that even the IP addresses for the gateways here for both of the networks should be assigned also statically. We cannot assign them dynamically. The only dynamic IP address assignment should be go for the end devices, not the intermediate devices. So the last host IP address, that will be 192.168.1.126, and the subnet mask here should be 128. So the default gateway for the router is that one, the default gateway for the server itself. So that's the default gateway. Although we did not assign it yet, but never mind. Let's just assume that the IP address for the default gateway of this point here should be obtained from this range here, from the range, from the first range. And most likely, as I told you before, the gateway usually takes the first host IP address. The first host IP address, not the first IP address. The first IP address in the range is assigned to the network. This is the one. But the first host IP address is within this range here. So which means that it is actually this one. That's the first host IP address. So 192.168.1.1. So let me just assign it here, initially, and then after this I'm going to open the router interface and actually assign it there to the specific interface, fast Ethernet interface. So 192.168.1.1, and the DNS server, just leave it as it is. We're not working with the DNS now. Okay, so important thing is that to make sure that the subnet mask is correct and the IP address is within the range. So click close and then close. Now you need to immediately go into that router, since we need to activate the fast Ethernets. Let me just click here. So that should be 00, and that should be the 01 fast Ethernet. Yeah, that should be the FA1/0. So the 00 will be here. Trying to extend that, so that will be 00. Let me activate it and then assign the IP address just now I have been taken, 1.1, and that will be 128. Don't forget this, actually it has to be 128, otherwise you will have a conflict between the IP addresses in the in both networks. Okay, so since we are now in the router, let's just again let's even assign the the gateway address for the second switched LAN network, which is under here, activating the interface first, and then assign the IP address. That should be, let me just go and confirm the IP address. The first range in the IP address, that will be the first host IP address, which is this one. Okay, the first host IP address in this network is 192.168.1.129. So 192.168.1.129, and that's the subnet mask already being configured, since the router now already learned that there is a new subnet mask other than the default one. So close that, and now you have the router already configured. So let's just go back into the server, because now most of all of our work will be here in the DHCP service within a server. Let's just come back to the settings. So now the subnet mask determined based on a /25. What is the subnet mask we have been using? I think we have already been explaining this. We have been explaining this even from the beginning. This is why I told you these information are important, because you're going to use them later on And yeah, here we are actually. You have to determine the subnet mask based on the prefix /25. Knowing that, we already know, I mean, like that /25 subnet mask is already going to be 255.255.255.128, because that will be 24 bits plus 1 bit here. So 24 ones, meaning that, yani. So we have 24, I mean, like 8 ones in each octet. So converting them from binary to decimal will give us 255, and another 255, another 255 for the third octet, and then the fourth octet we have only the leftmost bit in the, in the octet is 1, and the rest of them is 0. So this is why here the value of the first, I mean, like the value of the leftmost bit, in the fourth octet is 128, converting it into decimal. So there we are. So you already know how to identify the the subnet mask. Third point here, it is to know what is the gateway. So the gateway, based on the instruction, you should actually assign the fast Ethernet interface that is connected to the server LAN. What is the gateway of it? طبعا it's been, and by default, I think you need to understand that usually the fast Ethernet gateway over here. Let me just pick you back here. So that's the gateway to the server here. So it should take the first IP address. So what is the IP address of it? So that that's basically the first IP address in this range. The first IP address in this range here, which is this one, as I told you, okay? Because we have already assigned it. We have been already configuring it. So 00, that's the one. It has already been configured. So DNS server, same as the IP address of the server. Yeah, so that's actually the this is a very important information here. So the DNS server, according to the scenario, it asks us to assign it as, same as the IP address of the server. So this means that the DNS server in here in the desktop, let's just change it or add it to be typically same as the IP address of the DHCP server. That's possible also. Okay. So let me just close this. So now I have been configuring the DNS server in the server itself to be the same as the IP address. So task D, based on the above network, create the required DHCP pool. So let's just go with the DHCP pools. So first of all, to enable DHCP assignment on the 3 PCs. Okay, so let's just now go and create the pools. And so here the pool should be from, the DHCP service should be obtained from services. And first of all, we need to, turn on the service. All right, so here we are. So the first pool should be the pool that identifies, or the pool that describes the, the IP addresses here internally. And we are here in this server. Imagine that if we have another PC that is connected to the, which is connected to the router in the same network, which is existed in the same network. So we need, of course, to assign a pool. So the first pool will going to use the same pool, ID. By the way, you need to consider that this is the default pool name. There must be at least one pool named only server pool. And then the rest of the pools, yes, you can just create them according to your according to your definition. Okay, but you need to make sure that the first pool is already named as server pool, because this has already been programmed in the router itself, that the default pool name is server pool. This is the default pool name, and whatever extra pools to be added, you can just give them any names you would like. Okay, so let's just now we are going to configure the default pool to be to assign IP addresses based on this network here, which is, of course, let me just even provide the network addresses. That will be much better for our reference. So the router to the LAN will get to the server will get that IP address. So that will be 192.168.1.0. 1.0, that's the first network, and so the .128, and that's the second network here. Okay. All right. So now the default gateway for that. Now we are going to assign the to create an address pool, IP address pool for this network. So we're going to use the same pool name because this is the default pool, and then the default gateway should be 192.168.1.1, right? Because we are working on this network. So that's the default gateway here. Okay. And the DNS server, I think the default gateway is not needed here because you know why? For the simple reason is that the server is already existed in the same network that we're going to create a pool with for. This part of the scenario, it is exactly same as this scenario, that we don't need to create a pool. We don't need to create a default gateway in the server pool. If you remember the last settings, you can just revert back with the video, can just play back the video to to confirm this. Okay, so since we are working here, we're going to assign an address pool for this network, and this network is the same network where the server is, where the DHCP server is working on. So we are not going to use the default gateway here because the communication will not be getting out of the network for this IP address. It will be only you. This server will only be providing its information locally, not over the network. Not over the rest of the network, because we are still we still haven't yet assigned the server pool for this network. Okay, so this is why here I'm going to put this to be all zeros. Okay, and now let me just start the IP address. So let me just see here what is the requirements to follow them. There are no specific requirements, by the way. There are no specific requirements, but anyway, I'm going to so the last IP address in the server static. So this is the static IP based on the above network. Create a required DHCP pool in the server to enable the DHCP IP address assignment in the PCs. So the pool name, what is it, and the default gateway, that will be okay. So this is actually for the second scenario, or this is for the creating an IP address or creating a pool for the second network. We are here actually now. We are about to create a pool for the the first network, which is the server network. Okay. Anyway, so let me just start the to provide the starting IP address. Any value could be 10, since it's not been mentioned in the scenario. Since it is not mentioned in the scenario, we can just assign any value just for practice. Okay, and the maximum number of addresses, let's just assign this to 20. Okay, so I'm going to save this. Okay, then I have saved that. So let me now add a new entry. So to add a new pool, I can now modify the pool. So let me just call this as LAN switch LAN. Okay, switch LAN, and the default gateway to it. Now I can assign the default gateway here, because now this server, now I'm already in the server here, trying to provide a configuration here. So in order to assign, in order for this server to reach this network, it needs to go through this gateway. Now that's the time for assigning this IP address as a gateway here. Okay, so I'm going to use 192.168.1.1. That's the gateway, and then the DNS server will be, if you remember, the DNS server has been configured to be the same as the IP address of the server. You can confirm this by going into the server IP address configuration. You can, if you remember just now, just a couple of minutes ago, we were defining the DNS server to be same as the IP address of the server, so which is 192.168.1.126. And let me just start the the maximum number of users. It's also not being given. We can just simply assign it by ourselves. So the the starting IP address, so that will be, let's just start this from 130. Okay, since of course the first IP address in the why did we start from 130 here? It is because the first IP address, the first host IP address in this network is starting from 192. So it has to be anyway not less 192. We cannot assign any IP address less than 192 with this network. So the starting IP address has to be one address within this range, within 192.168.1.192.168.1.129 to maximum, or the last IP address, 192.168.1.253. So any value, any IP address between them could be a valid starting IP address. So let me just start it from 135, for example. And the maximum number of hosts, assigning it to 40. Okay. And then here I'm going to create, I'm going to click add, because I'm not going to modify the existed one, but I'm going to add a new entry because this is a new pool. Clear? So now we have the server pool, okay, and which is the pool that is going to feed the IP addresses to this network, and we have the local pool, which is the default pool, as you can see here. Okay, so now everything should be fine. There should be everything should be fine. So let's just now go and try to test if it is possible. Not before testing, actually, I think there is one command that we need to go through to enable. Now, so that these PCs understand that these IP addresses to be obtained are going to be used from this server, so we need to enable this in the router. So the router has to get a permission, or the router has to enable or to provide a permission for the server to send its IP addresses to these PCs. So that should be provided in the router here. So there is actually one command, couple commands that we need to use here. So over here, these are the commands. So now let's just, before we go to the command, let me just fill up the information here according to the scenario after we have configured. So based on our configuration, let me just take you back into the services, DHCP services. So now we are talking about the pool that describes that assigns an IP addresses for the three PCs. In another word, we're talking about this pool. So now, information that we have been entering in this pool, what is the pool name? Then this is the pool name, SWLAN. It could be any name, by the way, but the most important thing, do not add white spaces, do not use a specific, special characters. So the pool name should not include, any kind of special characters or white spaces. It should be all letters or numbers. Letters and numbers and mix. Okay, and the DNS server, or the default gateway, that should be the default gateway of the router, which is the IP address of the router fast internet that connects the switched LAN. So that's the default gateway. And then the start IP address, this is the start IP address. This is as an example, as I told you, it is not fixed value. And also the maximum number of addresses also it is not a fixed value. That's based on this is just an exemplary value, just to identify or to complete the configuration. Okay, so those are the information that we've been providing. So now let me just go to configure the router interface. We have been, I think, configuring this even before, and now this task is to assign an IP addresses for the both interfaces in the router, and we have done this actually, as you can see here. So 1/0 sorry, that would be 1/0. It should take the IP address 129, which is the first IP address in the range. So that's actually easy. So now from the router we need to enable, we need now to enable the router to give a permission for the server to assign an IP addresses for its local network. So now this is actually to be implemented in the router. So we need now to access the router here, and we go to CLI mode, which is the command line mode of the router configuration. Okay, so and then we type the interface of the switched LAN. So now we need to access the interface of the switched LAN. So by typing interface, so you can see here I'm typing in interface FA0/0, hit enter. So I've already entered the interface 0/0. Actually, this is 1/0. In any way, I need to enter this interface. Maybe because the configuration here in the lab is a little bit different. Okay, So by mistakenly, this router was configured, or like the links here was configured to assign this to, to assign the switch LAN to, instead of being interface 00, I assign it to interface 01. But anyway, since we understand that, the idea here is that we need to access this interface, whether being 01 or 10. Whether being 00 or 10. So it is interface 10. So let me just, divert this to be interface 10 actually, because I need to access that interface. Okay, so I want to access this interface, and now to this interface I want to teach it, or like I want to let this interface know that there will be like an IP helper for the DHCP server who is going to access you in order to assign IP addresses for these PCs. So that's the important, this is the purpose of this, of that command here. So using this command here, IP helper address, that will be the IP address of the server. Okay, I'm just going to type IP helper address 192.168.126, 168.1.126. Okay, so press enter, and then that's it. So click exit or write exit. So there you are. So now we have identified the helper IP address. The helper IP address, this is the command to enable, to teach, or like to let the interface of the router aware that there will be a server, or like there will be like an IP address which will be responsible for assigning, which will be responsible for managing the IP addresses for your internal host, or like for your host in the internal network. Okay, so now there is nothing left but only to enable the DHCP in the in the hosts here in the PC. So let's just now go and for each one enable the DHCP host. If there is nothing wrong, everything should be fine. Seems that there is a problem. See that's this message here indicates that there is a problem with the configuration. There should be some problem somewhere here or there. So let me just go and try to examine where is the problem. Most likely the first thing that you need to suspect of is that this is the one in here. Okay, so we need to go back and check this. So the default gateway here, I believe that this is the problem in here. The default gateway, it's not that one, it's supposed to be this one. See, the default gateway to this pool, now we are talking about what is the default gateway to this. It is not this gateway. Rather, it is the IP address of this gateway. I mistakenly provided this here. So I need to convert this into 129. Yeah, 129. Why 129? You can go back here. So the first IP address in the range, 129, over here, which I have used this address to be assigned to this, to be assigned as an IP address to this interface. So now I can even confirm this back again. So 192.168.1.129, it is the IP address of this interface. So whenever determining the pool, or like whenever creating the pool of IP addresses, we don't need to use this IP address as the default gateway. Rather, we use the default gateway for the actual network, for the destination network that we're going to create a pool for. So in other words, we are using the IP address, we are referring to the IP address of that gateway. Okay, so let me just close this. I can just double check that from here. So that's actually /00/10. So that's the IP address of /10, typically the same. It is exactly the same IP address. So this one should be the one that to be identified here as the one that should be identified here. So 126. Let me double check that. So this is 129 actually. Okay, and the DNS server. So let me just save this. Don't forget to save, because we have been modifying that. And so 10/10, yeah, exactly the same. 192.168.1.129, and here the DNS or the DHCP server for that, it is the default gateway, of course, it is 192.168.1.129. okay, of course the DNS server will be left same طبعا زي ما احنا عارفين. يعني you can see that this is the DNS server that we have been defining. It's already here. Okay, we have been defining this before, so we use the same IP address. Hopefully now things are going to, hopefully things will work as it is, and you can see here immediately the IP address has been captured. You don't need even to reactivate the DHCP. You can see that. So it has been assigned to 192.168.1.135. Why starting from 135? You can go back and examine that. If you open the server and then you go to the DHCP, you will find the starting IP address from this pool. طبعا don't forget to go to the correct pool because we have two pools here. Okay, if you go here to the second pool, the first pool here, you will find that the IP address, the first host IP address to be assigned by the pool is 192.168.1.130, which is that one here. So now close that, go for the second PC, you will find that the subsequent IP address is being given. Activating the DHCP to see 136 is being given. So this, and also you can see this message. If you notice that message here, DHCP request successful, of course here this means that you should have no problem in the configuration. All right, so the last one in here, indeed you should have no problem. So 137. So let me just use that here to, for example, ping. And now I'm going to ping the IP address of what? Let me ping the IP address of the first host here. So now I'm already in PC2. I'm going to ping PC0. So ping 192.168.1.135, right? The first IP address which has been given here is 135. And there you are. You have 100% success of pinging. And then you also can ping the the default gateway here, which is that one, 192.168.129. So dot here .129. You should also have no problem. You can even ping from one end to another end. So now you're in PC2. You can even ping the server itself. So the server IP address is 192.168.126. You can confirm this here from the server itself. So the IP address of the server is 126. And this is it. And also, of course, in any PC can ping now the server. PC1 should be able to ping the server. So ping 192.168.1.126. You should have no problem actually. All right, so this is actually the activity that you are supposed to achieve here. So basically, we have been able to enable the DHCP service over two LANs, considering two IP address pools. And actually, the most important thing here, as I told you, you need to be careful in defining and creating the address pools. Let me again revise with you what we have been doing here, particularly in the portion of the of the DHCP. In order to create the local, DHCP pool, so we use the default DHCP pool where it has the default name. طبعا this name is the default name. We don't need to change it. You cannot actually change it, okay, because it must be there, okay, because this is the default pool. And since this is the local, since the server is existed in the same network, that we're going to identify a pool for, so we don't need to provide any gateway or DNS server, okay, because here the server will assign IP addresses locally to whoever is connected to this network. But because we have another network here, the scenario is different. Of course, you already know now what is the starting IP address, which is usually given in a scenario, and also the maximum number of users. It also can be given in a scenario, but in our scenario we didn't give this. But most likely, if you if you are going to be examining this in the exam, indeed I'm going to give you this. I'm going to provide these details for you in order to provide them. In order to configure them in the correct place. So the second one, which is the most important one, that's the pool that identifies the IP addresses or creates the IP addresses for the switched LAN. So we need to create a different name other than the first name, and then assign the default gateway to be the gateway for that LAN, not the gateway for the server. Do not confuse this. And actually that was the last mistake actually that we have been, confusing. That from the server, the default gateway, it is not the gateway here. It is not the gateway that represents the server. Rather, that's the gateway that, that allows the server to reach that switch network, which is that one. Yani the gateway of that network. The gateway of this network. It is that one here. So we provide an IP address for this gateway, 192.168.129, and the DNS server for sure we have been identifying it to be as a DHCP server. So this has been provided since the beginning. The DNS server and the DHCP server IP addresses is the same. This is what you need to understand from this point, is that the DNS server IP address and the DHCP server IP address are the same. And that what you can indicate from here is that if you go here to see the configuration of the DHCP server, that's the IP address, and it is exactly the same IP address used for the DNS server. This is because later on we're going to talk about that in the next lab, is that the services of DNS server and the DHCP server are almost same and correlate to each other. So this is why even it is highly possible that one physical PC or like one physical machine, it can be used to work as DHCP and DNS in the same time. This is why here it is possible for that to use the same IP address, okay? And of course here we have been, presumably, we have been assigning the starting address to be from, let me just come back here, the starting IP address to be 192.168.1.135. we already know why 135. Important thing, this is just any figure, يعني هذا طبعا عبارة عن مثال. But the important thing here is that you need to stick to the range of host IP addresses, so that the starting IP address should not exceed this range, should not exceed the range from 129 to 253, because that's basically the host IP address range that you're entitled in this network, which is entitled for this network, okay? And of course the maximum number of users, again, this should be given in a scenario, however it's not, but anyway, in the official cases, in the official questions, you of course you'll be given such a detail. Well, and then after this, after we have been configuring this, we need now to enable the server, and that's the most important information here. We need now to tell that router here that this server is going to access your interface here in order to provide a helping in the IP address. This is why here we have used that command IP helper address, meaning that this interface or the router here will already be configured to know that there will be a server or there will be an entity which is going to help in providing an IP address for that network, and that's going to be the IP address of the server, as you can see here. So that's the IP address of the DHCP server, and by typing, of course, the IP helper address, but where? Not in general. We need to provide this interface. This is not any interface, by the way, particularly طبعا whether it is correct or not. المهم إنها that's the interface here, whether that interface is 00 or 01. Most important thing is that you need to know that this is the interface. We need to access the interface here by this command, and then inside that you need to provide the the IP address helper IP address. Like the IP address of the helper device, and then exit the interface. So and then you can simply just go and activate the DHCP server as what we have been seeing here. Okay, so this is it. And finally we have the connectivity. We have been just doing the connectivity just now, testing to ensure that even we are we're able to provide end-to-end connectivity from the different PCs to each other, and also from the PCs to the to the gateway of the other network, also and further to the server itself, to the remote end user in the second network, in the other network. Okay, so this is all about the activity. I hope it has been informative for you. I hope you could catch up the the values that you're supposed to learn. And so with that, in order to harden your understanding, I have actually provided you this kind of reflection scenario. It is a similar scenario to the previous one, but it's like with a little bit of challenging. Let me just, trying to, to open up your skills and trying to challenge your skills a little bit. So please just, try to work with this, and so that you can actually provide, the configuration in a similar way. By the way, of course, there are not much of information has been mentioned here, but anyway, try to redo the previous scenario here, but using this information here. طبعا, there are some information that you need to assume, as I told you just now, such as the starting IP address and the maximum number of addresses, because of course they have not been given here. So this is why we just need to assume them, because this is just a practice question. This is not an exam question or assignment question. Okay, so this is all from my side. I hope that has been informative for you. Thank you, and I will see you inshallah in the next class. So thank you.